So if we just go back to basics, so forget what we've been doing recently. If this is a parallelogram, okay, how would you work out the area of a parallelogram? No. Just base times height, isn't it? Right. Base times height. Because I don't know how you've done it in the past, but there's two ways. You either put another one on and make that, or you cut off a triangle, and and so to show that this triangle goes over here, and you actually get a rectangle. There's lots of ways that we could have gone through, right? But the area of a parallelogram is that, right? But what they're now saying to you is, based on the fact that we've now got a formula for a triangle. So do you remember we can use a parallelogram to go half base times height for a triangle? And that explains, because normally people start with their rectangle, don't they? And they split that in half, but that's only a right angle triangle. So as soon as you make it a parallelogram, they're like, oh, but they just multiply the sides together. So that's where I'm at M2 at the moment, explaining that. But you guys know it's the perpendicular height and then the base. Yeah. All right. But if we go from the triangle back to parallelogram, so we do the opposite way, this time, let's say we've got an angle theta, and this time we actually know a side. So do you remember before, if we knew the side, that wasn't actually useful, was it? We actually wanted to know the perpendicular height. We couldn't use the side length of a, right? But now, remember we've got a formula for that triangle, and it would be, the area of the triangle would be A times base times, no, what was the formula from last? Remember we had,
sine.
Yeah, so A times base times sine of that angle, but we'd only want a half of it, yeah? Right. But we can now use it to work out what the area of a parallelogram is. Because how do I go from the formula for the area of a triangle to a parallelogram? Yeah. This angle's the same, isn't it? The same sides. So you just double it, don't you? So the area of, so this is the triangle, and the parallelogram one would just be A times B times sine theta without, okay? You got that from the book? Then let's have a look at the next one, which is, if we've got this triangle, what type of triangle do they say it is? So it's an equilateral triangle, right? And they've called it S for side. Yeah. And the area of this triangle is what? Don't read it from the book. Let's get there. So it's S, S, and S. So we've got this angle here, yeah? So it would be 1/2 multiplied by S multiplied by S multiplied by sine theta again, yeah? But the S is, don't go too fast. That's S squared, yeah? And then we've got sine theta. However, what do we know about an equilateral triangle? Yeah, we know that theta is 60 degrees, all right? And from what else we've done, we also know that the sine of 60 degrees is equal to what? 3/2, isn't it? Do you remember why? Special triangle, yeah? So then if I put that into that here, I've then got the area is actually 1/2 of S squared multiplied by root 3 divided by 2. And if I combine the fractions, what do I get? Exactly, root 3 over 4. All right, so that's that one. Okay, let's have a look at the next one that they've got then, which is what kind of triangle have I just drawn? An isosceles, actually, right? I'm using their diagram. So what I've done is then, if I consider this a section of a circle, well, that's the radius and that's the radius. Here's the arc, okay? If I wanted to know the area of a sector or a segment, a sector, the area of the entire sector, not just the triangle bit, if I wanted to know that area, what would it be? So I would need to have theta. So it'd be
by r squared times theta over 360.
Okay, so we're going to do, it's theta out of 360 of an entire circle, yeah? Pi r squared. Got that? All right. Is there any other way to write that? It's not in the book, by the way, so. Which is, do you remember that? So if I did it in radians, but let's go back to degrees. All right. So we've got a formula then. All right. But we've got something else now, haven't I? Because we've also got a triangle. And is it possible to work out the area of that triangle? So what's the area of that triangle now? So we've got the area of the triangle plus the area of the segment, this being a segment rather than a sector. Okay. So what would the area of the triangle be?
R squared sine of theta.
R squared sine theta, yeah? All right. Anything else there? Aha. Okay. But now we've got to work out what the segment is. But don't we need to write this maybe in a different way round? Yeah, so let's look at what we would do for the segment separately first. So what's the area of the segment? The segment itself would be theta divided by 360 multiplied by pi r squared and then subtract 1/2 r squared sine theta. So instead of looking at area of the whole thing, let's think of it as the segment. Yeah? Makes sense? So that's the formula there. But can you see how they go from degrees? Do you see where the radians version comes from? Yeah? In the book there? So this practice 3 is about using those combinations and applying that formula that we've now got for using the angle and the sides of a triangle, not just having the height of the triangle, right, to try and work out. So for instance, should we do one of those questions? Should we have a look at 1A just quickly? All right. So we know this is a, excuse my drawing, that wasn't very good. So this is a sector. We've got 32 degrees and we've got 2 centimeters. Okay. And it says find the shaded area. So I only want that region there. So what would we do? Yeah.
First you can find the area of the whole thing using,
Yeah, so let's work out the area of the sector first. So it's the sector, by the way, this is a good exam tip, is to write out in words what you're doing. So I've got the area of the sector subtract the area of the triangle, yeah? That's what I'm actually doing. So it helps an examiner like think, oh, what am I actually doing? I'm communicating it. And it helps you with your thought process when you start getting lots of numbers together. So what's the area of the sector?
5, 4,
So it's 32 degrees out of 360 degrees multiplied by pi multiplied by 2 squared. Yeah, do that. Minus, what's the area of the triangle now? 1/2 times 2 squared times sine 32 degrees. Got that? So I've just written out without simplifying it yet. Up to you how much simplification you want to do. So we've got 2 squared is 4, cancelled with 360. So I've got 32 over 90 times pi. Subtract half of that's 2 sine 32. Right? And how are you going to do that? Put it in your calculator. Go for it. What do you get?